Then in Algebra 2 for subclaim C, again, we're still reasoning, but our reasoning returns to this kind of major focus on reasoning about a given equation or a system of equations, about the number system, and then included as well in this is reasoning about trigonometric functions, unit circle, and data. And so reasoning kind of permeates this Algebra 2 test in the sense that, you know, kids are going to have to be able to determine whether or not a conclusion is generalizable. And once kids get to Algebra 2, they've worked with enough function content that it kind of is a natural extension to get them to then, you know, use the principles from Algebra 1, use some of the geometry that they've been working on to then bring it full circle to this trigonometric, unit circle, data analysis, family of function, transformation of functions kind of, you know, problems. Okay. So subclaim C focused on reasoning. Subclaim D focuses on modeling. Now, what's interesting of note, and if you remember, if you followed the Common Core development, initially when the standards came out at the high school level, modeling was its own contents domain. That ended up not appearing in the final version, but modeling is one standard for mathematical practice. But if you notice here at the bottom, what we really have is all of this, many, not all, but many of the standards for mathematical practice being summarized here. So when kids get their results back on these end of course tests, they will know not only how well they performed on the content, but also how well they performed on these practices. And that is a very different approach for high school testing. And so let's look at kind of what that means for each of these three end of course tests. Again, as with reasoning, you'll see reference here to these high school D statements. That comes from not the standards, but that comes from that blueprint document. And especially with modeling, you want to take a look at the blueprints document, because they'll say things like how big the data sets will be, what kind of things will be in the data sets, those kind of things, and other kind of constraints and conditions. So I would encourage you to sit down with that blueprints document, and maybe in our next session we'll do that in more detail. But for Algebra 1, and you'll see though in modeling there's a real continuity from Algebra 1 to Algebra 2 to geometry. And what the modeling involves is really about the level of independence students have in creating a plan, implementing that plan, and then analyzing that plan. And what you see here is a scaffolding that becomes less and less as we go from level 2 to level 5. So in level 2, I'm using stated assumptions and approximations. That's the same for level 3, but look what happens in level 4. I'm not just using stated assumptions, but I'm also making assumptions and using micro models. So that's an important change. So as a student who performs at level 2, I can simplify a real world situation, but pretty much everything's laid out for me. And as I want to move to levels 4 and 5, I've got to be more independent and explicit about what assumptions I'm making that aren't self-evident in the modeling situations. In addition, in level 2, I just have to identify important quantities. Level 3, I start to illustrate the relationships between important quantities. And then level 4, and 5 for that matter, I start mapping those relationships. So you can see here a real increase in student initiated modeling. So as I move from level 2 to 3 to 4 to 5, I'm going from everything being given to me to becoming more of a, you know, they give you the skeleton or they give you the outline and you've got to fill in and put the flesh on the bones. So again, as with reasoning though, For high school kids, if they come to you and they have not had a lot of modeling experience, that is a developmental process that you'll have to lead them through. Now, there is some content listed in the Algebra 1 that involves kind of applying proportional reasoning and percentages, and then you will also see in modeling, as you go up the performance level, students' use of language and kind of accuracy in applying their model becomes more proficient. Now, so for subclaim D for geometry, again, it's still modeling. It still has that same kind of moving from stated assumptions to making assumptions, moving from identifying important quantities to illustrating the relationships to mapping the relationships. But for geometry, certainly, our modeling is going to be about, a more kind of, geometric based scenarios, but also then interpreting it, your results, and modifying the model if it hasn't served the purpose will be something that not only happens in geometry as you dig into this, but in the other end of course tests. And I'm not going to belabor Algebra 2 because you'll see it's virtually the same as Algebra 1 and geometry, in that I'm still having to look at the modeling, moving from, okay, here's everything laid out for you, to becoming more and more of a independent, student-led kind of performance. So the moral of the story is on subclaim D is that we're trying to wean students off of the teacher, I guess you would say. And so you may not be able to do some things at the beginning of the school year, especially these first couple years with Algebra 2 students who come to you and have not had the benefit of the Common Core. But, levels 4 and 5 at the beginning of the school year in Algebra 2 in particular might be very, very difficult. And so you want to maybe focus on some levels 2 and 3 things in the beginning, that my ultimate goal after the first of the year or towards third and fourth quarter is that students can do this levels 4 and 5 more successfully and more independently. Before we finish up this session, I do want to briefly mention subclaim E, because it does exist, but not for high school. Subclaim E is an effort to capture student fluency. Now, if you look at some of the PARCC other documents, like the model content frameworks or some of the blueprints, they'll talk about fluency in other conceptual areas. But for the PARCC assessment purposes, they've created these number sense fluencies for grades 3 through 6. If you're interested in them, you can watch my other sessions or simply download those performance level descriptors and look at subclaim E. But I did want to mention that briefly, just in case you hear someone mention subclaim E, that it does not apply for 7th, 8th, and high school. But there are subclaim E information for grades 3 through 6. It includes not only kind of the fluency in terms of an efficiency or a time element being, timely in your calculations, but also the numbers you can work with and the level of accuracy. So that's just a brief highlight of subclaim E. So that gives you kind of some major highlights for the performance level descriptors for high school. Several things to note. That the information today is intended to get you started on the process of calibrating your curriculum. The performance level descriptors give us much more information about what the expectations are for students in the PARCC assessments than we've had for any other kind of assessment. We need to use that information. And my advice is to use it to really calibrate, first of all, your assessments. Do my assessments ask students to perform at levels 4 and 5, at the strong command and distinguished command levels? If they don't, then your students are not going to have a prayer of performing at those levels on this PARCC assessment. So my first step is to incorporate those kinds of student exhibitions of knowledge in my assessment. So then that logically brings you to the next step, which is, okay, so if students are going to have to perform this way, what am I doing in my discussions with students, and what am I doing in my lesson plans to prepare them for that performance. And so you may need to take a critical eye at some of your units in terms of the focus. If I'm only doing, for instance, factoring for factoring's sake, and I'm not connecting factoring to zeros of a function, to understanding end behavior and changes in increasing and decreasing intervals on functions and how the zeros help me determine that, then you're not getting to that level. So you want to start with your assessments and then map backwards to those discussions and those lessons so that you're really fostering student learning at the strong command level minimally. You've got to shoot for level 4. And if you can, then level 5. And certainly, as I mentioned before, your honors classes, your advanced classes, those pre-AP classes should absolutely be benchmarked to level 5. If you don't, students are going to really struggle when they get to that advanced placement or that post-secondary kind of readiness idea. They've got to be able to do stuff with the content. So that gives you kind of a starting point. Again, as I mentioned at the beginning, if you have any questions or any feedback on this session, I really welcome your emails at the address listed on the screen. I thank you for your listening today, and we will have other sessions sometime in December available. And certainly, if you're interested in other grade levels, I have parallel presentations for elementary, intermediate grades, and middle school. Thank you, and have a good day.